Namaste children, welcome to today's class. We are discussing the fourth unit, practical geometry. In the previous class we discussed about construction of a quadrilateral when four sides and one diagonal is given. That is one diagonal and four sides. Today we are going to discuss case 2, that is when two diagonals and three sides are given. Two diagonals and three sides of a quadrilateral are given. How to construct a quadrilateral? Here, so example, construct a quadrilateral ABCD. So we have to construct a quadrilateral ABCD. Given that BC is equals to 4.5 centimeters and AD is equals to 5.5 centimeters, CD is equals to 5 centimeters. So these are the three sides, BC, AD and CD. Now the two diagonals AC is 5.5 centimeters and BD is 7 centimeters. So two diagonals and three sides are given. How to construct this quadrilateral? Now given data in quadrilateral ABCD, so it is given BC is 4.5 centimeters, AD is 5.5 centimeters and CD it is 5 centimeters, AC it is 5.5 centimeters and BD it is 7 centimeters. Now we require a rough diagram. So draw the rough diagram first. Rough diagram. Yes. Draw the rough diagram. So here quadrilateral ABCD. Yes. This is quadrilateral ABCD. Where AC is equals to how much it is? 5.5 centimeters. And AB is given? No, it is not given. BC is given, that is 4.5 centimeters. And AD is given, how much it is? 5.5 centimeter. Similarly, CD is given, that is 5 centimeters and AC is 5.5. Now the other diagonal BD is given. How much it is? 7 centimeters. BD is 7 centimeters. Like this, we will draw the rough diagram. Then we will draw the construction. So now construction. The third heading is construction. Yes, how to draw it. So as usual, so again we use triangle properties, that is SSS congruency. When we know three sides of the triangle, we can draw this what it is a triangle. Now you see here AC. First step is draw AC as usual. The diagonal AC is equals to how much? It is 5.5 centimeters. Yes, this is 5.5 centimeters. So what is this? It is AC, that is 5.5 centimeters. Now to locate, first we will locate here point D here. So to locate point D, we know AD is 5.5 centimeters and CD is 5 centimeters. As usual, we know that is AC is 5.5 centimeter. That is three sides of the triangle, we know. So first construct the triangle. So now to locate point D, draw AD is equals to how much? 5.5 centimeters. We know this line segment is also how much it is? 5.5 centimeters. So without using scale also you can use this and you can draw. Yes. So from point A, draw an arc of radius 5.5 centimeters. Now from point C, here it is 5 centimeters is there. C to D is 5 centimeters. Draw. Yes, this is 5 centimeters. Now from point C, cut an arc of radius 5 centimeters. And we will locate this point as what? D. What is this point? D. Point D. So first step, draw AC is equals to 5.5 centimeters. Second step, from point A, draw an arc of radius 5.5 centimeters. And third step, from point C, draw an arc of radius 5 centimeters, which means join AD and CD. Join AD and CD. Yes. Join AD and CD. Like this. Join AD and this is a CD. Yes. Now we have to locate point B. We have to locate. Now to locate this point, see here we have a triangle is there. BD is one side and what it is 4.5 centimeter is there. This is BC and CD is there. CD we know here it is how much? 5 centimeters. Again we use the concept of SSS congruency and we will construct one more triangle. Now AD is how much it is? 5.5 centimeters and this is how much it is? 5 centimeters. Right like this. Now to locate point D, so B, from point C draw an arc of radius 4.5 centimeters and from point D draw an arc of radius 7 centimeters. BD is given how much? 7 centimeters. That is the second diagonal. Now from point C draw an arc of radius 4.5 centimeters. So this is of course this is 4.5 centimeters. So from point C, draw an arc of radius 4.5 centimeters to locate point B like this. Next, from point D, BD we know how much it is? 7 centimeters. So draw an arc of radius 7 centimeters which intersects the previous arc at a point called D. Yes. So this is it is intersecting. So the previous arc is not intersected. You try to extend the previous arc which is of 4.5 centimeters radius till it intersects. Yes, 4.5 centimeters means yes, like this we will take. Yes. Now this is the arc. The previous arc should be extended so that it intersects. Yes. Now it is intersected. What we will take that point as? That point will take as what? B. Now join AB. We don't know how much it is. Join AB and join CD. Join AB and join CD. And join BD also. Join BD. Like this, we can draw this construction. We can do this construction. Now BC is equal to how much it is? 4.5 centimeters and BD is how much it is? 7 centimeters. BD is 7 centimeters. Like this, we will construct a quadrilateral when we know the 3 sides and 2 diagonals. Clear? Now we will write the steps of constructions. Now the steps of construction. So the first step we did, we have drawn the line segment AC is equals to 5.5 centimeters. Draw AC is equals to 5.5 centimeter. Then from point A, draw an arc of radius 5.5 centimeters. Third step, from point C, draw an arc of radius 5 centimeters which meets the previous arc at point B. So here the 2 arcs are intersected and we have taken that point as D. Fourth step, join AD and what it is? CD. Then fifth step, from point C, draw an arc of radius 4.5 centimeter. From point C, draw an arc of radius 4.5 centimeter. Now the sixth step, from point D, draw an arc of radius 7 centimeters. How much? 7 centimeters, which meets the previous arc at point B. At point B. Then seventh step, join AB, BC and BD. AB, BC and BD. Then quadrilateral ABCD is the required quadrilateral. Like this, when we know 3 sides and the 2 diagonals of a quadrilateral, we will construct the quadrilateral in this way and we will write the steps of construction. Now we will discuss the question from exercise number 4.2. Now exercise exercise number 4.2. First bit. Construct the following quadrilaterals. So you are asked to construct a few quadrilaterals. Three bits are there. First and second bit, they are direct quadrilaterals. How can you construct them is just now the previous construction what we did, that is the quadrilateral ABCD. In that similar way you have to do the two questions. You can do it. Now the third bit is rhombus. Construct a rhombus, bend, B-E-N-D, bend. Bend is the name of the rhombus, in which BN is equals to 5.6 centimeters and DE is equals to 6.5 centimeters. 6.5 centimeters. If you see BN alternate letters, DE alternate letters, what it represents? The diagonals. It means here the two diagonals of the parallel of the rhombus are given. The two diagonals of the rhombus are given as 5.6 centimeters and it is 6.5 centimeters. How to construct it? Here we use the property of diagonals of the rhombus. What is the property related to the diagonals of rhombus? It is the two diagonals are unequal. Yes, 5.6 centimeters and 6.5 centimeters unequal. And the two diagonals bisects each other perpendicularly. It means each diagonal is divided by the other diagonal into two equal parts at right angles. So here we use the concept of the perpendicular bisector. What do you mean by a perpendicular bisector? A line segment which divides the given line segment into two equal parts at right angle. For example, AB is a line segment. So this line segment is bisected by another line segment CD. It is bisected means here these two segments are equal. OA is equals to OB. Both are equal at right angle. Then we can say that CD is the perpendicular bisector of AB. Perpendicular bisector of AB. What is perpendicular bisector? A line segment which divides the given line segment into two equal parts at right angle. Now how to construct it? We use this concept in constructing this rhombus. Now we will discuss how to construct a perpendicular bisector to a given line segment. Let AB is the given line segment. How to draw the perpendicular bisector? As we have discussed in class 6th. How do we construct? We will take the more than half of the radius as the half of. We will draw two arcs from point A and from point B by taking the radius which is more than half of the given line segment. What happens if you take less than half of this line segment? The two arcs will not intersect. If you take exactly half of that given line segment, the two arcs will intersect on this line segment. That is the reason why we will take more than half. Now we take this is more than half of the line segment. More than half of the line segment. So from point A, draw an arc, and from one arc above and one arc below of the given line segment AB. Now without changing the radius from point B, cut the previous arcs with same radius from point B. Now both arcs are intersected here. Both arcs are intersected. Now look at these 2 points as M and it is N. Join these 2 points. This line segment is called the what? Perpendicular bisector of AB. So it is perpendicular bisector. If you measure, we get these angles are 90 degrees, and if you measure OA and OB, both will get equal. So how to construct a perpendicular bisector? By drawing two arcs from both the end points of the given line segment by taking the radius which is equals to more than half of the given line segment, and by joining those 2 points we get the perpendicular bisector. Now we will discuss how to construct this rhombus. So first, by the given data, what is given for the construction that we have to write. So what is the given data here which is given? Given in rhombus bend the given data. BN, one diagonal, is equals to 5.6 centimeters. The other diagonal it is 6.5 centimeters. Now we require the rough diagram. Rough diagram of this rhombus is, this is the diagonal DE, which is of 6.5 centimeters, and the other diagonal is 5.6 centimeters. What is the other diagonal? BN. Now BN, how much it is? 5.6 centimeters. Right here it is 5.6 centimeters. Now join BD, BE and BN. This will give us the required rhombus of bend. This is the rough diagram. Only we know the two diagonals. Now how to construct it? We'll discuss construction. Here very few steps are there. Construction. So first step, draw DE is equals to 6.5 centimeters. Draw DE is equals to 6.5 centimeters. DE is equals to 6.5 centimeters. Yes, this is DE. How much it is? 6.5 centimeters. Now the second step is we have to draw its perpendicular bisector. That perpendicular bisector will act as the second diagonal of the rhombus bend. So how to draw the perpendicular bisector? By taking more than half of this radius. Yes. So this is more than half of this. Draw an arc from point D, both one above and one below. Then from point E with same radius, draw two arcs. They intersect the previous arcs. So from point D, take more than half of the radius of the line segment DE. Draw two arcs, one above and one below. And from point E, draw two arcs. They intersect each other, and we give the name for this as M and N. Here M and N. MN is the perpendicular bisector of DE. Now join these two, we get the perpendicular bisector. Yes. So join this, we get the perpendicular bisector. Yes. Like this. MN is the perpendicular bisector. If you measure and they intersect each other, let this point is O, and if you measure this is 90 degrees, all angles will get 90 degrees. Now this is what is perpendicular bisector. Now the diagonal of the second diagonal of this rhombus will lie on this perpendicular bisector. What is the length of the second diagonal? It is 5.6 centimeters. As I said, it bisects each other, means from here the diagonal, half of the diagonal will be there, and from here half of the diagonal will be there. Half of the diagonal is how much? It is 5.6 centimeters. Half of 5.6 means it is 2.8. 2.8. Half of 5.6 is 2.8. If it is 6 centimeters is the diagonal, then half of 6 is 3 centimeters. If it is 7 centimeters is the diagonal, half of the diagonal it is 3.5 centimeters. Now from point O, cut an arc of radius 2.8 centimeters. So it is 1, 2, and it is 3. So cut an arc of radius 2.8 centimeters. How do we got 2.8 centimeters? It is half of the diagonal. Like this, we cut it on this perpendicular bisector. One arc above and one arc below. Now those 2 points we take them as what it is. B. This point is B, and this point it is what it is. So we have this N. So we can take this perpendicular bisector as X and Y, because in our rhombus itself we have N is a bend. So now this point is N. So now we have located point B and point N on the perpendicular bisector of DE. Now BN is the what it is, the diagonal. How much is OB? It is 2.8 centimeters. How much is OM? It is 2.8 centimeters. Now what is the length of the diagonal? Is 5.6 centimeters. The whole length of the diagonal is 5.6 centimeters. Now join BE, BD and DN and NE. All you join, you get the required rhombus. So BE and join, that is BD, and now it is BE. Join EN, and join DN. Yes, this will give you what the required quadrilateral, that is the rhombus bend. So like this we will draw the rhombus, what it is, bend BE and D. If you join this correctly, you will get, yes, a bend rhombus. So here we are using the concept of perpendicular bisector because the two diagonals are perpendicular bisectors to each other. Now we will write the steps of construction. Now steps of construction. Here we have 5 steps. First step, draw DE is equals to 6.5 centimeter. Second step, draw XY is the perpendicular bisector of DE which intersects DE at a point called O. So draw XY is the perpendicular bisector of DE which intersects DE at O. Third step, from point O, cut an arc of radius 2.8 centimeters. This is 2.8 centimeters and this is also 2.8 centimeters, which is half of the length of the second diagonal, that is 5.6 centimeters. In that half it is 2.8 centimeters. On either side of DE, that means one above DE and one below DE, and locate those points as B and N. B and N. Then fourth step, join BD, join BE, join BN and DN. Now rhombus BE and D is the required rhombus. So like this, we will construct when we know the two diagonals of rhombus by using the concept of perpendicular bisector and the property of its diagonals. That is, the diagonals of a rhombus are perpendicular bisectors to each other. Is it clear, children? Thank you.